Okay, so this is in your textbook. If you have a look at your textbook, it will be under (4B), anti-differentiation. Okay. Okay. So why we call it anti-differentiation? If you look at the first concept that we have, that is, if I say given y is equal to a, whereby a is a constant. Okay, so can you please tell me what is dy over dx? Stephanie, can you please mute yourself?
Sorry, Miss.
Okay, what is dy dx?
0.
Yes, a constant never change. So the rate of change is 0. So now antiderivative, we will write it as this symbol. This symbol can mean sum, what we have learned yesterday, what we learned yesterday. And for this one means is anti-differentiation. Okay. So now if I integrate 0 with respect to x, I will get back my y. And constant, usually we use c to represent constant. In this case, the constant, okay, I put here as c, okay, so that we are consistent. So this is the first one that you have to remember. So this is called anti-differentiation. In calculus, we call it integration. Integration, okay? So this symbol, are you okay? So we also know that if I say given y equal to ax plus c, where a and c are constant, okay, now if I ask you, what is dy dx for this case? What is dy dx for this case? Can someone tell me?
A.
A, you are right. So now, if I integrate a with respect to x, what do I get? I should get back my y, am I right?
Yes.
So that's why if you integrate a constant, you will put a constant times x plus another constant. Right? So that is the meaning of antiderivative. Okay, now I go to number 3. If I say given y is equal to ax squared plus c. Okay, now can you please tell me what is dy dx?
2ax.
2ax plus 0, am I right? So now, if I integrate 2ax what will I get back? I will get back my y, am I right? Which is ax squared plus c. So that is the meaning of antiderivative. You get me?
Yes.
Okay, now let's have a look at how are we going to tackle antiderivative question. Can you have a look at example 1? Example 1 is say given a function y equal to x ln x. So the first part of the question, they will ask you to find dy dx. Can you please do that by yourself now? What you need to do, you need to use products rule. Are you done? Take this as your u and take this as your v. So your u prime will be 1, your v prime will be 1 over x. So your dy dx will be v u prime plus u v prime. That means derivative of v. Okay? Simplify. So you get this. So in order to solve part B, listen here. In order to solve part B, because with the word hence, so I'm going to use my antiderivative concept. So I'm going to start with telling myself that if I integrate ln x plus 1, that is my dy dx, what will I get? I will get back my y, am I right? So remember this. If you integrate, so everyone have to bear in mind, if you integrate your dy dx with respect to x, you will get back your y. So that is x ln x. So you have to write down this step first. Don't look at the question yet. Whenever you have hence question, use the information that you get in part A and the knowledge that you have about antiderivative, write down the first equation. Okay. So the next concept you have to learn is if there is a plus sign or a minus sign, then you are allowed to split this into two integrals. Are you clear? So that is the second step you have to take. So now you start to modify. Now you ask yourself, do you know the integral of this? By using concept 2. Can you tell me what is the integral of that? If I integrate a, I will get ax. The plus c, you can leave it. You plus how many constant at the end is still a constant. So can you tell me what is the result of this?
X plus C.
Okay, I told you already the plus c, we can just leave it behind. Can or not? At the end only we write. One constant plus another constant is still a constant, okay? So we just at the end write a general constant. So I just put this as x. Can or not? Do I know the integral of this? I don't know. So I just write down ln x dx. Okay? So far, so good?
Yep.
Okay, so now if I write it this way, if I integrate ln x dx, I write it as x ln x, take away x. Is there anything wrong? No, am I right? Because I just move this term over to the left-hand side, right-hand side. Okay, now, what the question want me to do? What the question want me to do? So I'm going to write in another page. Huh? So at the end, I got this. After I modify, I got this. Yes? So that is the integral result of the integral of ln x dx based on my idea of antiderivative. So this is the very important step. So in the exam, if I give you a question like that, that's how I give you the mark. You got this? 1 mark. If you start for part B, you write down this, you get 1 mark because you know the meaning of antiderivative. Then here is the modification. So you got this. Is that what the question want you to do? No. What the question want you to do? Okay, we now only go back to the question. The question is, integrate phi ln x dx. So do you know how to read this? This is read as phi times of this integral. So if I want to know phi times of this, can I get it from here? Can I get it from there? Class? Can I get it from here if I want this?
Yes.
So what should I do with this one, the one that I tick?
Multiply by 5.
That's 5.
Multiply by 5. Yes, you are right. For the whole equation, am I right? So I will have integrate 5 times of this. I can write inside, I can write outside. It doesn't matter. Will be 5 times of x ln x minus 5x. Then over here, after I've completed everything, I just put a plus c. That is fine. Do you get me? Hello? Hello?
Yes.
Are you okay?
Yes, miss.
Yeah.
So, like for example, this one, I can change the question like that. I can have another question. I ask you to, another question, okay? Okay, I can use the same function. I can have another question. I can ask you to, hence, find the integral of ln x over 2 dx. It's the same thing. The way I work out is the same thing because this one is read as half of ln x dx. Am I right? So you just time half, then you get the answer. Do you get me? So when you do an antiderivative question, very important, you make sure you differentiate correctly. After you have differentiated, when you do part B, based on your answer in part A, write down the antiderivative concept. Then observe what you must do to get to what they want. It can be of any form. It can be of anything I like. You get me? Hello? Are you okay?
Yes, miss.
Okay. Let's do question 2, example 2. I let you try it by yourself first. Okay, example 2.
Miss, is it from the textbook or?
No. It's from the one that I asked you to download.
Okay.
Okay, example 2. Okay, they say given a function. Those who don't have, you can look at the board. Given y equal to x e to the power of x squared. Part A, find dy over dx. Then part B, they ask you to hence find the integral of, this one is quite straightforward. You can straight away get the answer. Are you okay? Okay. So for part A, u is x, v is e to the power of x squared. So du over dx will be 1. dv over dx will be copy down the whole thing times by the derivative of the power. So your dy over dx will be v du over dx plus u dv over dx. Okay, so the common factor is e to the power of x squared. Factorize out 1 plus this multiply with this, you will get 2x squared. right? So now I remember this concept. So this is a concept that everyone have to remember. I differentiate, I integrate my dy dx expression with respect to x, I will get back my y. Am I right? So I straight away come to here, I write down. If I integrate ex squared, 1 plus 2x squared dx, what is the answer? Is the y. And what is the y? There is x squared. Then I have to put a plus c. Any indefinite integer, you must always put a plus c. You get me? The c can be 0 or can be anything. Are you clear? So is that what the question want? Yes. So my job is done. So is this important? This is important.
Miss,
Yes.
can you please repeat when should we put C, like plus C?
Because any expression given to you, I can plus a 0. Am I right? Still remember? I can split into 2 parts. So what is the integral of 0? So now you know why. Anything you plus 0 is still the same thing. So that's why it's a must to put a plus C. You get me? You can plus 0 to anything, you don't change the thing. That is how you work. Are you okay?
Yes, Miss.
Okay. Can we please go to our textbook? Can you please go to exercise 4B? Exercise 4B, page 106. Okay, let's have a look at part 1. Question 1, part A. Okay, they say find the antiderivative of this. That means I want to look for this. I want to know what is the answer. So I'm going to ask myself this question because I don't have the formula. So I'm going to ask myself, my y must be what in order I can get the dy dx as with the x there. My y must be x squared, right? So my dy dx will be 2x. Am I right? Hello?
Yes, Miss. Yeah.
So if I integrate 2 times of x dx, I will get back my y, am I right?
Yeah.
So now this is 2 times of so if I integrate, so I can divide by 2, correct? The whole equation. Am I right? So this one will become x squared divided by 2 plus c. Am I right? So now let's try part C. If I want to integrate x to the power of 5 dx. So we know that when we do differentiation, the degree will go down by 1, am I right? So now can you please tell me what should my y be? In order that differentiation will be x to the power of 5, my y should be x to the power of what?
6.
6. So if I differentiate this, it will be, am I right? So according to my concept of integration, if I integrate my dy dx, what will I get? What is the answer for this one? Can someone tell me?
X to the power of 6. Right?
Yes, you are
Yeah.
right. X to the power of 6. So therefore, this is 6 times of this, am I right?
Yes.
So therefore, my integral of x to the power of 5 dx will be x to the power of 6 divided by 6 plus c. Yeah. So you look, there is a pattern there. This is power 1. This one become power 2. This one divide by 2. This is power 5. Power 5. It become power 6. Then divide by 6. So can we come out from here based on these 2 examples? If you continue with the rest, you will get the same. Yeah. So now, can we from here come up with a formula? If I have a number times by x to the power n dx. Okay, integrate. So what should the power be?
N plus 1.
Good, thank you. Then what should I divide with?
N plus 1.
N plus 1, then plus c. So this is the formula you have to remember. But there is a condition for this formula. Can n take any value? N cannot be -1. Am I right? If n is -1, -1 plus 1, you get 0. Something divided by 0 is undefined. So this is the first simple formula for integration that I will talk about it in this afternoon at 2 o'clock lecture. I'm going to teach you all the formula of integration. Got it?
Yes, miss.
So that is how mathematicians get the result. They base on their antiderivative idea, then they come up with a general formula for you. I'm using antiderivative concept here. Can or not? So every part that you do in 4B, part 1, you have to use that. Then you predict a general formula. I predict for you already. Yeah. Okay, let's look at question 2. Let's look at question 2. Yeah, they say find the antiderivative of that. Okay, now let's look at part A. You are supposed to get the integral of e to the power 2x dx. So now, what should my y be? We know that when we differentiate exponential term, correct? We'll copy down the whole thing times by the derivative of the exponential, am I right? The power. So my exponential should start with y is equal to e to the power of 2x. Am I right? So what is my dy dx here? What is my dy dx here?
2e
2e power 2x.
Okay, you are very quick. 2e to the power of 2x. So now if I integrate 2 times of e to the power of 2x dx, what will I get? I will get back my y, am I right?
Yes.
Which is
Yes.
e to the power of 2x. So now 2 times of e to the power of 2x, the integral is e to the power of 2x. So 1 time of it, integral of e to the power of 2x, will be equal to e to the power of 2x. The 2 bring over, this is 2 times e to the power of 2x divided by
2.
2x.
2. Should be 2 here. Correct? Then plus a c. So this is e to the power of 2x over 2 plus c. Yeah. That's for part A. Okay, now for part 1. This is part 1. Huh? Okay, let's look at part 3. Part 3 is you are supposed to integrate e to the power of half x. So now, in my equation, the original function that I want to differentiate must have this term, am I right? So what is dy over dx for this case? What is dy dx for this case? Can someone give me the answer?
1 over 2 e power 1
Yes.
over 2x.
Yeah. So it's copy down the whole thing times by the derivative of this, which is half. Correct? So if I integrate my dy dx, I will get back my y. Am I right? So if I want to make it left-hand side, I divide by half. Right-hand side also I divide by half. Can or not? The half and this half cancel. So integrate e to the power half x dx is equal to divide by half means times 2. So look, this means yes. So look, if here is half, here will divide by half. So now can you tell me what is the general formula? If I integrate e to the power of bx plus k, it doesn't matter, dx, what will the answer be? What will the answer be? Yeah, yes?
EBX plus K over B
Correct.
plus C.
Yes. So remember, over here, this one must be linear. If it's not linear, you cannot use this formula. Okay, from here we get two general formula. Later I will mention it again. Okay, in the textbook they ask for what is the integral of e to the power kx dx. I purposely add another constant, is fine. So this one will be e to the power kx over k plus c. This is what the textbook want for question 2b. K can be any real value, it doesn't matter. So can I leave number 3 with you?
Yes, Miss.
Okay, I'm going to give you one more example. Yeah, we will work together, okay? Because I want to teach you another meaning. Okay, I will say, am I too fast? Are you okay with this?
Yep.
Yeah, okay, let's go on with this. Okay, one more example. Okay, I say, okay, given y is equal to x e to the power 3x. Okay, then I will say part A, find dy over dx. Okay, then part B, hence find the exact value of integrate okay. Okay, you do the first part first, then I will lead you into the second part. I will tell you what is the meaning of the two number there. Okay. Using products rule, I can use quotient rule also, depend on the question I give you. If you are done with part A, let me know.
Done with part A.
Okay, I just repeat for those who need. So U is X, V is e to the power 3x, okay? So U prime, 1, V prime, copy down the whole thing, times by the derivative. Okay, so dy dx, cross multiply, 3x e to the power of 3x plus e to the power of 3x. Yep. Can I write like that?
Yeah.
Okay. So
Yes.
now, to solve part B, where am I supposed to start? The moment the question has hands, means you have to start from here. If I integrate 3 times of x e to the power 3x plus e to the power 3x dx, what is the result? Remember, integrate the expression of dy over dx with respect to x will give me y. So what is the result here? Junje,
Yes.
what is the result here? Can you tell me the answer of this integral?
Y lah.
What is y here?
X E 3x, right? Power of 3x.
Yeah. X e to the power of 3x. Okay, good. Now, we have done that. So now, you look, is this what the question want? No. So I told you, if there is a plus, what can we do? Split into
it out.
2. Yeah, split into 2. Right? So ask yourself, do you know the integral of this? Based on just now that formula that we have here, we can know, correct? Okay, so we are going to go back to here. So we can know. So this one is 3 times the integral of this. Plus the integral of e to the power of 3x is e to the power of 3x divided by
3.
Thank you. Okay, are we done? Okay, now, if you look at here, we just want this part, correct? We don't want 3, am I right? So can I divide the whole thing by 3?
Yes.
Yes. So I'm going to write okay, if I write like that, is that correct?
Yep.
Okay, good. So now, look, there's 2 numbers there. As long as there's a number, you don't have to bother whether to write plus C or not. So now I write down 6 to 4 x e to the power 3x dx is equal to, I put a square bracket here. I put a 6 at the bottom, 4 on top. So I must sub from the top. So I'm subbing the top. Take away, I sub the x from the bottom. Are you okay?
Yes.
Now you simplify, then you get the answer. So how many e to the power of 12 here? You just key into your calculator 4 over 3 minus 1 over 9. Are you okay? So that one you can get it from the calculator. So at the end, so I'm going to calculate. $11. This one will be 11 over 9 e to the power of 12. Take away. $17 over 9 e to the power 18. That's it. This is called the exact value. Okay, you want to test whether your value is correct or not. You can get the approximate value from your calculator. Then, can you evaluate this from GC. When the question say evaluate means you can get from GC. Do you know how to evaluate this? From your GC? The moment they say evaluate means telling you you can use your GC. So can you evaluate this using your GC? Do you know how to use it? Hey, no answer.
Yes.
I
Okay.
cannot find the button.
Is it maths and then
Is it Fn integral, like Fn int? Oh yeah, it is.
So you can key in, put in the number 6, put in the number 4, then type in the equation. Then you put enter. Then the answer is out. Everyone must know how to evaluate a definite integral. When we say definite integral, that means there is a number here. Always the top minus the bottom. After you integrate already, then only you can substitute. So what is the answer?
Negative 1, 2, 3, 8.
Negative?
Negative 1, 2, 3, 8.
Cannot
2.
be negative. I don't think it's negative.
it is negative?
Is this negative?
Yes.
Oh, okay, okay. Is it negative? Because 4 is smaller than, yeah. Okay, negative?
1, 2, 3, 8.
1, 2, 3, 8 point.
6.
Okay. Can or not? So everyone must know how to evaluate. You get me?
Yes.
Okay. So antiderivative question always start with this step. Then you won't get wrong. Then you modify. Are you fine? Okay, afterward we will talk about the fundamental and we talk about the rules, okay? So the question on the area, I've shown clearly with the answer given. Okay, there are some integration that we will, you after today's lesson, then you will know what to do. Yep. Is that okay?
Yes, miss.
Okay, so I will see you afterward. Yep, 2 o'clock.
Thank you,
Bye
miss.
bye, miss.
Okay,
Thank you, miss.
yeah,
Thank you, miss.
welcome.
Thank you, miss.
Thank you.
Thank you.
Yes.